Could we save people $1,200 a month by simply just changing our diet? Let's talk about it. Alright, now that I grabbed your attention with a financial incentive, I actually am speaking about the cost of what's referred to as Ozempic. And now this is a new medication that's being prescribed heavily across America and across the entire world to help with weight loss and insulin resistance. And if you don't remember anything about this drug, the most important thing is it is what is referred to as a GLP-1 agonist. And now this simply means that this drug will act exactly like a hormone inside of our body called GLP-1. It will bind to the receptor and cause the same functions to occur. And I think the unfortunate thing is that we keep prescribing this medication to people instead of giving them advice as to how they can actually alter their diet to mimic this medication. So that's what I'm going to try and provide you with today, is an alternative solution to getting on a medication. It would simply just be changing your diet. So I'm going to first kind of walk you through a little bit of physiology, but don't worry, it's actually going to be pretty interesting. So we have what are referred to as K cells and L cells. And these are located in the small intestine where the majority of our carbohydrate and lipid digestion will occur. And these cells are referred to as open sensor cells. This simply means that they are stimulated by an interaction with nutrients inside of the small intestine. Now, it's actually very important to understand where these cells are in the small intestine. K cells are more abundant at the top of the small intestine, and they release a hormone called GIP. And the L cells are more abundant at the bottom of the small intestine, and they release hormones including GLP-1, GLP-2, PYY, and oxyntomodulin. So for thinking about trying to produce more GLP-1, we need food to interact with the L cells, meaning it has to get farther through the small intestine. And we will get to this in a little bit later. However, I want to talk about insulin. So the hormones that I mentioned that are produced by the K cells and L cells are referred to as incretins. And it is estimated that these incretins are responsible for between 50 to 70% of our insulin production. And now this is demonstrated by providing the same amount of glucose either intravenously or orally. So we can either ingest 50 grams of glucose through our mouth or put 50 grams of glucose directly into our bloodstream. And when we put the 50 grams directly into our bloodstream, we bypass the small intestine, therefore there is no interaction with these sensor cells and no production of incretins. And the result is that the levels of insulin that we inevitably produce is between 50 and 70% lower, and we also have much higher blood sugar for much longer periods of time when it's directed directly into our bloodstream. Sorry, I misspoke. When it is injected directly into our bloodstream. And the reason for this is because both GLP-1 produced by L cells and GIP produced by K cells increase our insulin production by binding to the pancreatic beta cell, which is simply just the cell that's responsible for producing insulin. They have receptors on the pancreatic beta cell, and when they bind to the receptor, they aid in the synthesis and the release of insulin. And now, the GIP, which is produced by the K cells, will also increase the levels of glucagon. And what glucagon does is actually quite contrary to what insulin does. Insulin is responsible for storing nutrients inside of cells, but glucagon is responsible for taking stored nutrients, breaking them down, and secreting them into the bloodstream. Which means that GIP not only increases our ability to store nutrients into the cell, but it also increases the availability of nutrients inside of our bloodstream via glucagon. It appears that GIP is a very anabolic hormone, and too much GIP can actually cause very rapid body weight increases. Conversely, if we look at GLP-1 produced in the L cells, it will increase insulin but decrease glucagon. And it also appears that GLP-1 will actually act at the level of the brain and decrease our appetite and increase our satiety. So what GLP-1 will do is it will actually allow glucagon to stop liberating fuel from storage and allow insulin to store what we already have in our bloodstream, therefore having profound effects at lowering our blood sugar levels. And now I mentioned satiety. Let's talk just a little bit about satiety. The only hormone in the body that increases hunger seems to be ghrelin. and it is made inside of the stomach. Conversely, CCK, PYY, GLP-1, and oxyntomodulin all seem to decrease hunger, and remember, all of these hormones are produced by the L cell. So if we kind of recap this, it appears that stimulating the K cells will increase our blood sugar and fat storage because of the co-release of glucagon and insulin. Conversely, the L cells will result in satiety, a lowering of blood sugar due to the increase of insulin without the increase in glucagon. And this is why we can come back to the importance of their location, because again, the K cells are at the top of the small intestine and the L cells are more abundant at the bottom. Therefore, we must find mechanisms to bypass the nutrient absorption as much as possible by the K cells in order to promote nutrient absorption by the L cells to get the satiety promoting effects. And this is why it appears that easy to digest foods such as sugar seem to predominantly increase fat storage but not have much effect on our satiety levels. Conversely, it has been found that a very complex starch such as a boiled potato actually seems to be one of, if not the most satiating foods on the planet. Additionally, as long as these starch granules remain intact, it actually appears to not have a drastic blood sugar increasing effect. And I apologize, if I say blood sugar, it is the same thing as me saying blood glucose. Simply, it appears that the boiled potato is able to make it farther down the small intestine with nutrients still intact, and the nutrients can then interact with the L cells and promote all the effects of the hormones that the L cells produce. Another mechanism would be to eat foods alongside a bolus of glucose, which will slow its absorption, and this is why we have found that co-ingesting glucose with fat seems to decrease the blood sugar response. This is because the glucose will make it farther down the digestive system and then interact with the L cells. So I think the takeaway of this is that very easy to digest foods such as pre-broken down sugars in the form of a drink seem to have adverse effects on our blood sugar and do not seem to be as satiating as foods that make it down to the L cells. And now, in addition to satiety, it appears that GLP-1 also decreases gastric emptying. And now, this can actually increase our nutrient absorption because that means that the food will stay inside of our small intestine for a longer period of time, giving the small intestine more time to digest it and derive nutrients from it. However, this is very important because it could actually cause some digestive distress if maybe we are taking a GLP-1 medication and we are co-ingesting that with foods that are somewhat indigestible. Something such as fiber will actually ferment in the small intestine, and if we are eating a lot of fiber alongside a GLP-1 medication, it may increase the amount of time it has to ferment, causing more gas. Therefore, as counterintuitive as it sounds, we may actually want to decrease our fiber intake so we don't have two different things slowing down our gastric emptying, leading to gas, bloating, and stomach distension. But I do want to actually say, just to make sure, none of this is medical advice, and you should talk to your doctor before doing anything. But staying on the topic of GLP-1 mimicking medications, we can actually simply just alter our diet to promote our natural production of GLP-1 instead of relying on the medication. It appears that foods that help promote GLP-1 are complex carbohydrates that bypass the K cells. My favorites would include something like vegetables, potatoes, squash, and pumpkin. With that being said, food processing drastically alters the rate of which we absorb something. If we take pumpkin, for example, eating a whole pumpkin seems to have a much greater stimulation of the L cells because it takes longer to digest. However, a pumpkin puree will mostly be absorbed by the K cells and not reach the L cells. This is simply because the process of pureeing it actually breaks down the starch granules, making it quicker and easier to digest. Therefore, more of the nutrients are available to interact with the K cells at the top of our small intestine and will be absorbed there instead of further down the small intestine. The same is true for apples and applesauce, fruit and fruit juice, vegetables and vegetable juice, and other processed carbohydrates that will physically break down the structure of the carbohydrate. Simply, you will not get the same effect out of a fruit juice as you would out of eating the fruit in its whole form. But interestingly, we also ascertain more calories from a food that is already broken down than we would from a food that is non-processed. A food that is already broken down will absorb the majority of the nutrients early, and whatever residual nutrients are left will be absorbed by the time it reaches the bottom of the small intestine. Conversely, a whole food, we may not even have enough time to derive all of the nutrients from it because it is so complex and difficult to break down. Therefore, we will excrete some of the excess nutrients. But as long as our diet is nutrient dense, this could technically decrease the amount of caloric yield we get from it. And as long as we are getting the nutrients in at the end of the day, this could actually be beneficial for weight loss. With that being said, if you cannot digest it at all, there is no reason to do it because you'll just be causing digestive distress. Therefore, you need to find the correct ratio of processing so that you can derive as much nutrients as possible. For example, a food that is high in fat, like a peanut, seems to do this. Cooking peanuts allows us to derive more energy than it would be from a raw peanut. Grinding peanuts allows us to derive more energy than we would from a whole cooked peanut. And the same is true from protein. Cooking an egg makes it easier for the large intestine, where the amino acids are absorbed, to absorb more nutrients from the egg. One study in mice demonstrated that we derive the most nutrients from a food that is cooked and ground up, and the least digestible food is one that is raw in its whole form. However, remember that this raw whole food, we will also not be getting the nutrients out of it. Therefore, maybe the best way to do it would be to cook it and eat it in its whole form. But this simply just depends on what food we are talking about. We can also look at a process called hydrolyzation of protein, where we essentially pre-digest the protein before we put it in our body. Hydrolyzed protein causes a much greater insulin to glucagon release than an intact whey protein. What this seems to demonstrate is that when we ingest a hydrolyzed protein, we will produce more insulin and store more of the amino acids into muscle. However, it will also increase the storage of other nutrients into fat tissue. And because this hydrolyzed protein is so quickly digested, it will probably stimulate the L cells, meaning we will increase our production of glucagon and have more fuel in the bloodstream available for insulin to store. And now it also appears that the smaller the size of the molecule of glucose, the more insulin that we release. This means that for the same amount, like 50 grams of glucose, we will release more insulin to something that is already ground up than we will if it is in its whole intact form. This is simply the difference between a whole grain and a processed grain. We produce much more insulin to a processed grain than a whole grain. And this is because the glucose molecule is already ground up and it's much smaller and easier to digest. And the final thing I actually want to leave you on is something that surprises me and maybe many others, and it seems that fiber does not actually have an impact on our insulin response. Rather, it was simply the amount of mechanical processing of a given food that seems to have the impact on our insulin response. This is actually demonstrated by ingesting a food in its whole form, and then ingesting the same food after it has been processed and enriched with fiber. Despite having more fiber, the processed version of the food promoted a much larger insulin increase than the non-processed whole version. Therefore, it actually appears that studies that indicate that fiber has a benefit on blood sugar is likely because the foods that contain fiber are complex carbohydrates. And as we know, complex carbohydrates interact much more with the L cells than they do with the K cells, promoting the satiety and lowering of blood sugar effects that the hormones produced by the L cells will have. And now the last thing I want to say is that some insulin is important to facilitate proper physiological functions. It simply is the overproduction of insulin that increases our body weight, specifically body fat. But if we produce the correct amount of insulin, we can actually have proper blood sugar and normal fat storage and have all of the anabolic processes that are important, such as building bone and muscle. But sometimes we may overproduce insulin for a given amount of glucose because we have highly processed the food. As I mentioned, we will produce much more insulin to the same amount of glucose if it is processed. Therefore, we will store all of the glucose in our bloodstream much more rapidly, and we are much more likely to actually get what is referred to as reactive hypoglycemia. And this is simply where we produce so much insulin in response to a bolus of carbohydrates that we reduce our blood sugar too much and have low blood sugar levels. We then feel the need to eat again because our blood sugar levels are low, meaning our energy will be low and our hunger will be high. With that being said, I think I'm going to leave you guys on this last statement, and this is a fact that should not be unsurprising to anyone. It appears that humans have the most appropriate insulin to glucagon response to carbohydrates that we've eaten throughout our evolution, such as fruits and starches. With that being said, I really hope you enjoyed this and maybe you took something away from it. All of my contact information will be in the description. You can follow me on Instagram at Calvin_Scheller, and I hope you come back and listen to the next episode. Have a great day. Oh, and